In this problem here, I'm going to show you guys how to find the quadratic inverse of an equation. So the first thing we want to do is let's look at our equation here. We're going to do this algebraically, and then we'll talk about what it looks like graphically here. So the first thing we want to do is we are going to rewrite f of x as y equals, and then we rewrite what we have on the right-hand side. Now what we're going to do is we are going to switch x and y in the equation. So it is not y equals, it is x equals, 2 parentheses, y minus 3 squared plus 5. And the goal is to get the house. I like to call the set of parentheses in this problem, that is the house. We want to get the house by itself, or the parentheses by itself. So we need to get rid of the 5 and we need to get rid of the 2. We start with the 5 first because we always start with add and subtract. I'm lying to you a little bit here, but in this problem here, we're starting with add and subtract, and then we're going to do opposites. So the opposite of adding 5 would be to subtract 5 to the other side. So we say x minus 5 equals 2 times the house, which is the parentheses, and the 5 is gone. Now we need to get rid of the 2. The opposite of multiplying by 2 is to divide by 2. So we're going to divide everybody by 2 on the other side. So we go x minus 5 divided by 2 equals, and then we have the house, or y minus 3 squared in parentheses. And the opposite of squaring is to take the square root. So we need to get rid of the little 2. Well, to do that, we're going to take the square root of both sides here. So if I take the square root here, the 2 goes away. But I have to take the square root over here on the left. And when you take the square root of something, you have to use the plus or minus sign. And so let's move this over here. That leaves us with the plus or minus square root of x minus 5 divided by 2 equals y minus 3. We want to get y by itself, so we start back over with the add and subtract, do opposites. The opposite of subtracting 3 is we are going to add 3 to the other side. Take our square root of x minus 5 divided by 2. We add 3 to it, and this would be our answer. All right, let's take a look at a second example. So in this example here, we're going to look at some things graphically. Let's take a look at what we have up here that we've written down off to the side. Let me shrink this down a little bit here. It says you want to look for the diagonal reflection across y equals x, and the reflection, or the inverse at the very end, we want it to pass the vertical line test. If it doesn't pass the vertical line test, it is not a function. All right, so our first example here, we have our quadratic x squared plus 3, and then we have a table of data that represents that. So we want to plot our table of data. So we'll go negative 2, 7, negative 1, 4, 0, up 3, 1, 4, and 2, 7. So here we go. We'll try to make the u here, or the quadratic. Let's try that again. There we go. Now if I were to draw vertical lines through this, you will see here that each one of those vertical lines that I draw passes the vertical line test because it only touches the graph once. That quadratic is a function. So we want to inverse. We want to find the inverse. Well, if I take this table of data and I have x and y, inverse means switch x and y. Well, let's switch x and y. So instead of having negative 2, 7, we're going to have 7, negative 2. Instead of negative 1, 4, we're going to have 4, negative 1. So all we're doing is switching the x and y values in the table. So let's graph what we have in yellow. So we go over 7 and down negative 2, over 4 and down negative 1, over 3, 0, over 4 up 1, and over 7 up 2. And you'll see that we have what looks like a sideways looking quadratic, right? It's opening to the right. But here's the problem. If I were to draw vertical lines, like if I drew a vertical line right here through this, you will see that it touches the graph twice, which means this is not a function. So what we want to do is we want to restrict part of the original graph. And so what I want to do is I only want to look at the right side right here. I only want to look at the right side. Well, if I look at the right side of this graph that I highlighted and up here at the top, you can see that this coordinate here is 1, 4. Also want to look at this coordinate up here. This is over 2, up 7. And then we have this one right here, the vertex. We're going to say that is at over 0 and up 3. Those are the only coordinates I want to look at from the original table. Well, if I look right here, we have 0, 3, 1, 4, and 2, 7. So the reason why I highlighted that is because those are the only inverse coordinates that I want to look at. I only want to look at these 3 coordinates right here. So I want to look at over 3, 0, which is right here, over 4, up 1, which I'm highlighting in pink, and over 7, up 2. That's the only part of the graph I want to look at. I do not care about this bottom part of the graph right here. So let's just pretend like this is no longer there. It is gone. So all we have is what we just have up top in yellow. And if we were to draw or graph the line of reflection, which is y equals x, it looks like this. And so you will see that what I have highlighted in yellow up here at the top is a reflection of what I have highlighted in yellow right here on the bottom. So that is what our inverse is. We're restricting the domain or the x value. So that's what we want. Now we can go back and say, does the highlighted graph here pass the vertical line test? Yes, it touches the graph just once when I draw a vertical line. So what is the domain of the inverse? So we're only looking right here. Domain is how far left and right the graph travels. Well, the domain is, we start at 3. It's a closed circle. And if you look right here, there's an arrow going to the right. It goes to the right forever. The range is how low and high the graph travels. Well, if you look right here, the lowest it goes is 3. That gets a closed circle. And you can see that the graph is getting taller as it goes to the right. So it is going up forever. So there is our domain and range.